So this is our first lecture in the grade 11 physics course for university preparation. It is on motion and it is in the unit Kinematics. So everything in the universe is in motion. You might think that if you're sitting still at a chair, you are still moving because you're on the Earth, and the Earth is moving around the sun. Even the sun itself is moving around a black hole at the center of the Milky Way galaxy, and that black hole is moving relative to the universe. So all things are constantly in motion. When physicists study motion, they call it kinematics. And one thing I could note just as we're starting the course is you might see some words that are highlighted or in bold. It might be worthwhile to write some notes down to write the definitions of those words. And another thing, quite often you get on these lecture slides a symbol that looks like this. That is another key that this is something that you might want to copy down. So kinematics is the study of motion. And the note here says, to understand the motion of objects, we must first be able to describe motion. So physicists use a number of specific terms and units to describe motion. You've maybe heard of some of these. These are distance, speed, velocity, acceleration. One way to define motion is the movement of an object from one place to another relative to an observer. So some idea that we could use to determine if something is moving is this idea of a straight line segment between 2 points. So let's say we have a train, and that train is moving, and you're sitting inside the train. As the train moves forward, you're also moving forward. So you are not moving relative to the train. Now, if your friend was sitting at the station and watching you leave on the train, the distance between you and your friend would increase. So because that distance is changing, we can determine that motion is occurring. Here's another slide that you might want to copy down some of the notes. And again, you could use these lecture slides. You can print them out and write your notes down on them, or you can write them down in a notebook. I won't read through everything, but this slide here, it says that motion is the movement of an object from one place to another, as measured by an observer. And two objects are in motion. WRT means with respect to each other. If the straight line segment between them changes either in length, in direction, or in both length and direction. And this idea of motion being measured by an observer, that will come into play quite frequently in physics, especially when you get into your grade 12 university preparation physics course and in university physics, that the idea of an observer is important to recall or to reference in terms of motion. So let's talk through some practice problems. First, it says here, how can you tell if one object is in motion with reference to another? And the idea that we have is that we could use the straight line distance between these 2 points to determine if motion is occurring. So let me show you what this kind of means. Let's say we have an object here. This is object A, and this is object B. And here, this is in time frame 1. They are, let's say the distance between them is 5.0 meters. Sorry, I wrote that down a little bit. In a second time frame, A and B might be closer to each other. Let's say they're now 1.0 meters away from each other in time frame 2. We can now say that motion has occurred. Now, a situation where motion doesn't occur let's say in this time frame, I'm going to have A and B 2 spaces away from each other. So this time I'll use this as my reference. So this is a 2-meter distance apart. And in my situation time 2, let's say that A and B have moved, but they are still 2 meters apart. So A has not moved with respect to B. So no motion is occurring between A and B. There are a few other problems to look at here, so we will use those to understand when motion is occurring and when motion is not occurring. So here we have 2 golf carts that are traveling at the same speed in the same direction along a straight level path. Are the carts in motion with reference to each other? So this is the idea of you sitting in a train as well. You would not be moving with respect to the train, because as the train moves forward, you also move forward. Here the golf carts are traveling at the same speed. They're also traveling in the same direction. So if the first golf cart moves 5 meters, the second golf cart also moves 5 meters. And they're both moving in the same direction. So the straight line distance between them hasn't changed. Practice problem 3 says that if the engine of a freight train is pulling 5 cars around a gradual curve, is the engine in motion with reference to the last car? Now I know the answer is written there, but I'm going to show you this because this is an interesting kind of classical sort of problem in physics. Let me go back to the straight line distance. So here, this straight line distance here was 5 meters. Here it's changed to 1. So that's the idea of the changing straight line distance. Here that straight line distance was 2, and it still is 2. So again, motion occurs with respect to A and B. Motion does not occur with respect to A and B. In the situation with this train moving around a curve, let me define, here's my, this is my first situation. So my train will be here, and my carts will be behind it. So this is cart 1, 2, 3, and 4. This is time frame 1, and let's say the distance between each of them, just for sake of argument, is 1 meter, 1 space between each. In my time frame 2, the train would have made a curve. So let's make a bit of a curve here. Let's say that the train is here, the engine, and the remaining carts are in a circular pattern away from the train. So the distance from here to 4 might be 4 meters. The distance here to here, even if it is 4 meters, we don't know exactly what it is because we don't know the radius of this curve, but even if it is 4 meters, the direction has changed. So in this case, the question again was, is the, let me move the problem up, is the engine of the, was pulling 5 cars, the idea is the same, is the freight train engine moving with reference to the last car? And we can say that yes, the engine moves, and again, short form for with respect to, WRT, the last car. Okay, now a few more definitions here. We've talked about motion in general, but there's also some other types of motion we have to understand. Motion can be split into uniform motion and non-uniform motion. And what this basically means is we have a type of motion that is changing in speed and a type of motion that is not changing in speed. So uniform motion is constant speed in a straight line, but most motion you would experience is non-uniform. That's where we would have acceleration, things that slow it down, things that speed up. Moving around a curve is acceleration as well. So copy down the definition for uniform motion. That's motion or movement at a constant speed in a constant direction. And non-uniform motion is movement that involves changes in speed or direction or both. So let's look and see if we can find some ideas of when we have uniform and non-uniform motion. First example here, it says a rubber stopper is dropped from your raised hand to the floor. So if you are dropping something, if something's falling under the influence of the Earth's gravitational field, it will speed up. When you're holding it, it has a velocity of 0. As it gets to the floor, it's going to be increasing its velocity as it gets closer to the floor. So that is non-uniform motion because the speed of the rubber stopper is changing. For B, it says a car is traveling 85 kilometers per hour due west at a steady rate. So because it's not changing its speed, it has a constant velocity. That means that it is uniform motion. A motorcycle rider applies the brakes to come to a stop. So when you're stopping a vehicle, you are going from a time when you had a non-zero velocity to a time where you have a 0 velocity. So because you're slowing down, you're changing your speed. This is non-uniform motion. And for D, it says a race car travels around a circular track at a constant speed. And we kind of saw this with the train going around the curve. I'll explain it a bit more in some further lectures, but the idea generally is as you're traveling around a curve, even if you're traveling at the constant velocity around the curve, your acceleration changes because your direction is changing.